Alright, this video is on solving application problems involving differential equations. So we're basically going to take what we already know about solving differential equations, where we have a differential equation, we separate the variables, and we find the antiderivative on both sides, and then we solve. We're going to add some words to that so that we have to translate the words into mathematics. So let's just go ahead and take a look at what we have here. In problem number 1, they're talking to us about money in a savings account, and they have indicated that if the interest is compounded continuously. Now, you in pre-cal last year talked about continuous compound interest, and just as a reminder, you had the formula future value of your money is equal to the present value e to the RT, and most people refer to that as the PERT formula. So let's see how, if that's going to come into this problem, and how it comes into the problem. Number 1, for continuously compounded interest, the instantaneous rate of change of money. Now, we know that money, when it grows over time, and we know that because we're in calculus, the instant rate of change is a derivative, and if I let m in this case be money, then what they're really saying, think back to related rates, instant rate of change with money really says dp, the rate of change of money, over dt, rate of change of time. That's what we used to do when we did related rates, is directly proportional to. Now, directly proportional to goes back, is a throwback to Algebra 1 and Algebra 2, where we learned that y varies directly as x, or y is directly proportional to x. K is a constant of variation. In that case, it's the slope of a line. So if the problem says the rate of change of money is directly, there's my constant of variation, proportional to the money. So that's my differential equation. So now I have taken the words away and I've turned it into symbols, and now I'm going to use calculus. So they tell me in the next step to separate the variables and to solve the equation, just what we've been doing all along. So I'm actually going to write it up here. I'm going to find the antiderivative of both sides. Actually, I need to separate first, don't I? So let's get rid of that. If I separate, I will have dp over p, so all the p's are on one side. Now remember, k is a constant, and it doesn't really matter which side I have it on, but I'm just going to keep the p's on the left, and I'm going to keep the constant on the right-hand side. I'm going to find the antiderivative of both sides, so we know that dp over p, when you find the antiderivative, is ln of the absolute value of, sorry, I didn't mean to change the variable. Let's back up here a little bit. I apologize for my mistake. I'm thinking about a problem that's coming up. This should not have been dp, it's dm, the rate of change of money with respect to time. Alright, so please make that clarification. I'm glad I caught that. So dm, the rate of change of money with respect to time. So when I find the antiderivative, I'll get ln of the absolute value of m is equal to k. Now remember, k is a constant, like the number 5 or 7. So when I find the antiderivative, I get kt, because the right-hand side is in terms of t, plus c. When I use algebra to solve for m, I will get e raised to the kt plus c. Remember, we discussed in class that we could take this apart and that e to the c is going to be a constant. So when I simplify this, I have my money is equal to c, the initial value, e to the kt, which is, in different letters, the PERT formula. See, here's a, future value, principal, rate. Well, same thing, but we just have different variables. So we have used calculus to derive the PERT formula. Now the next part of the problem, I'm just kind of going on to number 5. The rest of this really is algebra, and you are going to need your calculator and use your calculator to evaluate some of this. So if you jump down to number 6, they're saying, all right, you got this formula, money, you derived it, is equal to c e to the kt. They're telling us from the get-go that at time 0, there's $1,000 in the account. So if I substitute that in and solve, I'll know that c, the initial value, is $1,000. And the other thing that they're telling me in the next part of the problem is that my interest rate, which is K, is going to be 5%. So I get e to the 0.05 t. Now from this point, they ask me, all right, you got this handy-dandy formula for money is equal to $1,000, e to the 0.05 t. The next thing they want me to do with a calculator, which I'm not going to do in the video, is to figure out how much money do you have 1 year, 5 years, 10 years, 50 years, 100 years. And I would literally just type that onto my calculator and figure out how much money I have. The last question says, all right, how long? So this time I'm not looking for money, I'm looking for time. How long will it take to double my initial investment? Well, my initial investment, or my initial value, was 1,000. Doubling that gives me 2,000. So I'm substituting that into money because remember, I'm trying to figure out how long that will take. I can divide both sides by 1,000 and get 2 equal to e to the 0.05 t. Recall from Algebra 2 that I can take the ln of both sides, and the reason I'm taking the ln of both sides is so that I can use a log property to bring the exponent of e down. So this would be e to the 0.05 t. Now my log property, so on the right hand side I just have the ln of 2. On the right hand side I can use the property of exponents that allows me to bring down my exponent, so I get 0.05 t times the ln of e. And we know from Algebra 2 that or pre-cal, the ln of e is just 1. So I can divide both sides by 0.05, and the amount of time that it takes for my money to double from $1,000 to $2,000 is whatever this number turns out to be using a calculator, years, and you would round off to the nearest year. All right, let's take a look at one more problem. We're going to look at example 2. It's in the next page of your packet. And your homework, as you can see, is from your packet, pages 11 and 12. I'm going to move this out of my way. Just going to maybe stick it right up there so I have the space down here to work. You run over a nail and the air starts to leak out of your tire. All right, so we're stumbling upon some calculus words. Edit, undo, and let's select the pen. All right, so the rate of change of air pressure. I'm going to use P for pressure. So I'm going to record the information. The rate of change of pressure with respect to time is equal to, here's my is, and it's another directly proportional, so there's my constant of proportionality, to the pressure. So you can see, wow, this is exactly the same scenario that we had before, but this time, instead of having money, we have pressure. Let me see if I can get a little bit more working space here. Good, that works. Okay, so then I need to, the question, letter A says write a differential equation. Done. Evaluate the constant of proportionality if pressure is 35 and the air pressure is decreasing at a rate. So in other words, dP dt is decreasing. Remember, we have to use a negative to indicate that the air is decreasing. So in other words, when P is 35, I can substitute my negative 0.28 in place of dP dt. The pressure is 35, so the constant of proportionality K is negative 0.28 divided by 35. All right? So I'm going to separate and integrate my differential equation. And again, it's the same process that we just did in the other problem. I find the antiderivative on both sides, and I get ln, absolute value of P. That's why I did a P in the first problem. I was thinking about this one. KT plus C. Go through the algebra, as you can see in the other problem, and we're going to end up with P equal to C, initial value, E to the KT. You also know that we just found K, so we can substitute that in, because remember that is a constant. And We also know that the initial value, 35, at time 0, so when 0, the pressure on my tire was 35, that can be placed or put in place of C. So my equation becomes P, air pressure, is equal to 35 pounds per square inch, which was already in the tire before it got punctured. E, my constant of proportionality is negative 0.28 divided by 35, multiplied by T. Sketching a graph of the function, which is letter C. I could put this on my calculator. Hopefully you realize that this is an exponential function, and if we were to graph in our calculator that over time the function is approaching 0 because the air in my tire is approaching 0. I'm not going to take the time to pull a calculator out. Letter D, what will the pressure be at 10 minutes? So let me copy my equation back over here. P is equal to 35 e to the negative 0.28 over 35. That's a decimal in there, t. So what they're really asking me here again is to take my calculator. When the time is 10 minutes, I substitute 10. I use my calculator to do the math. You get the idea. And I'll figure out how much air pressure there was. And then lastly, letter E says, all right, use the same, I'm running out of colors here, use the same equation, but this time not the the car. The car is safe to drive as long as the tire pressure is 12 pounds per square inch. So now I'm going to substitute 12 in place of P, and I'm going to find the time at which my tire pressure hits 12 pounds per square inch. And this is where I would use my algebra to get 12 over 35 is equal to e to the negative 0.28 over 35 times t. And from here I would take the ln of both sides. No, I do have more space. So I take the ln of both sides. This is the algebra maneuver. I would use my log property to bring down the power, so negative 0.2835 t times the ln of e. And again, we know the ln of e is just 1. So t is equal to the number of time, or the years that it takes, or the, not years, time it takes, is the ln of 12 over 35 divided by negative 0.28 over 35, which can be calculated on your calculator. And the time is in minutes. So hopefully this will help you and guide you in doing your homework problems. The first homework problem is on page 11, and it is dealing with baseball cards. Make sure you read the information carefully, record, but you're pretty much going to follow the same process to solve that problem. If you have any questions, please come and see me.